Have you ever stopped to think about what reality is? It seems like the answer is obvious. It's the world around us, the one we've been used to since childhood. It's your achievements, your work, your family, your children, your parents. It's you. You are real, right?
Hi, this is SkyMind, and today we're going to talk about reality, starting with science and ending with religion and philosophy.
The question of the nature of reality, traditionally seen as a topic of metaphysical reflection, in the 21st century has become a fundamental problem at the intersection of theoretical physics, cognitive neurobiology, and information science. Everyday human experience, the familiar world of things, family bonds, social achievements, and personal self-awareness, on closer analysis, turns out to be only the top layer of a complex, hierarchically structured system.
Exploring whether the world around us is an objective given or a complex product of biological and informational processing requires stepping beyond our familiar view of reality. To do that, we need to trace how the very same phenomenon reveals itself across different levels of description, from the macroscopic to the quantum, and from the neurobiological to the philosophical.
Physical deconstruction of matter, from atomism to quantum fields.
The classical perception of reality rests on the assumption that matter is a substance, something fundamentally solid. But modern physics offers a radically different picture. If we examine an ordinary apple through successive levels of magnification, its familiar shape and density dissolve, giving way to dynamic structures. At the macroscopic level, the apple appears as a biological object made of tissues. At 100 times magnification, a mosaic of plant cells comes into view, performing functions of energy storage and structural support.
Going deeper to the molecular level reveals complex chains of carbon, hydrogen, and oxygen. At the atomic level, the apple becomes a collection of roughly 10 to the 27th power atoms. Here, classical intuition hits the first paradox. Matter is almost entirely empty space. The atomic nucleus is about 100 trillion times smaller than the apple itself. And if an atom were the size of a football stadium, the nucleus would be like a grain of sand at its center.
Inside the nucleus, protons and neutrons break down into quarks and gluons. At this subatomic level, the idea of definiteness is replaced by probabilistic distributions. The apple stops existing as a solid object and turns into a wave of energy in an ocean of quantum fields. In this model, substance and force are simply two aspects of a single reality, quantum fields that fill all of space.
According to Frank Wilczek's framework, matter has three fundamental properties: mass, charge, and spin. This minimalist foundation is enough to describe any elementary particle. At the same time, the mass of the proton, the basis of most of the mass of the human body, is generated almost entirely by the energy of motion of quarks and gluons. This supports the idea that reality, at its core, is pure energy. If matter dissolves into fields, the next question is simple. What rules do those fields obey?
Fundamental interactions as the operating system of the cosmos.
All the complexity of the universe is built on four fundamental forces that define the rules for how matter and energy interact. Electromagnetic force, responsible for binding atoms into molecules and for the interaction of matter with light. It creates what we perceive as the solidity of objects and the diversity of colors. Strong interaction holds quarks inside protons and holds protons together inside nuclei. Without this force, atoms could not exist. Gravity, described by general relativity as the curvature of the fabric of space-time by massive bodies, it governs the large-scale structure of the universe. Weak interaction, responsible for radioactive decay and for nuclear fusion processes that allow stars to radiate energy.
These forces act according to universal, local, and precise laws expressed in the language of mathematics. Research suggests that at extremely small distances, these forces may unify into a single interaction, pointing to a deep internal unity of reality. But physics doesn't only change what matter is, it changes what time is.
The macrocosm and the nature of time.
Studying reality on cosmic scales shows that the familiar Euclidean geometry, in which parallel lines never meet, is only a special case applicable in weak gravitational fields. On the scale of the universe, space-time is dynamic and subject to curvature. Matter is distributed in the universe almost uniformly, forming a hierarchy from star systems to galactic filaments.
Relativistic effects and the dynamics of time.
Time, long considered absolute, is recognized in modern physics as relative. Special relativity predicts time dilation at speeds close to the speed of light, confirmed by experiments with muons, particles whose lifetimes increase because of their high speed as they move through Earth's atmosphere. Large-scale astrophysical studies in 2023, based on observations of quasars about 12 billion light-years away, showed that in the early universe, time flowed 5 times more slowly compared to the current epoch. This finding emphasizes that reality is not static. The very rhythm of the universe changes as it expands, an expansion that began with the Big Bang about 13.8 billion years ago. Now we turn from the outside world to the only place reality is ever experienced.
The biological interface and the neurobiology of perception.
If physics describes the external structures of reality, neurobiology investigates how those structures become subjective experience. What a human being calls reality is a visual and sensory simulation created by the brain from a limited set of signals. What are the limits of our sensory systems? Human vision is only a narrow window within the electromagnetic spectrum. Color is not an intrinsic property of objects. It is the brain's interpretation of signals from 3 types of cone cells sensitive to red, green, and blue light. A comparative look at visual systems reveals the subjectivity of perception. Most mammals have only 2 types of receptors, roughly analogous to blue and green, seeing the world in a limited palette. Honeybees see ultraviolet patterns invisible to humans, which they need to locate nectar. Mantis shrimp has 12 types of photoreceptors and perceives colors and polarization patterns that the human mind cannot even imagine.
So our perception is not a mirror of the world. It is an adaptive interface. Donald Hoffman, in his Interface Theory of Perception, argues that evolution selected not organisms that saw the truth, but organisms whose useful illusions helped them survive and reproduce. Space and time in this model are like a computer desktop, and objects are icons that hide the complexity of physical reality while allowing us to manipulate it efficiently. What if reality is a controlled hallucination?
Professor Anil Seth argues that the brain does not passively receive information, it actively predicts it. Perception is a controlled hallucination, where the brain matches incoming electrical signals to its internal expectations. We do not see what is out there directly. We see a model of what should be there based on our experience. This is supported by optical illusions in which the brain overrides raw data in favor of familiar patterns, for example, Adelson's checker shadow illusion. If the brain builds reality as a model, the next step is obvious. What if the deepest layer of reality is not matter, but information?
The informational paradigm and digital physics.
More and more scientists are concluding that the fundamental basis of reality is not matter or energy, but information. John Wheeler's idea, it from bit, proposes that physical objects and space-time itself emerge from acts of information processing. Within digital physics, reality is treated as the output of a cosmic algorithm. Edward Fredkin and Stephen Wolfram suggest that the universe is discrete and consists of minimal units of space, Planck length, and time, Planck time, like pixels on a screen. In this model, subatomic particles may be oscillations of quantum qubits, fundamental units of information linked by quantum entanglement. Some researchers, such as Roman Yampolsky, discuss the hypothesis that our world is a high-level simulation. In that case, the laws of physics are software code, and a superintelligence could, in principle, search for vulnerabilities in that code, ways to hack reality or escape a virtual environment. Computronium and the computational capacity of matter. Matter has an innate capacity for computation. From simple logical elements such as NAND gates, you can build any complex system. The term computronium describes a hypothetical substance optimized to perform any computations, turning the very fabric of reality into a computational substrate. The information capacity of the observable universe is estimated at 10 to the 88th power bits, exceeding what any imaginable biological mind could process.
Social ontology, constructing the collective world.
Human reality includes not only physical objects, but also social structures that John Searle calls institutional facts. Unlike brute facts, the existence of a mountain or an atom, social reality is created by collective intentionality, shared beliefs and rules.
Searle emphasizes that entities like corporations or money exist in a real way, even though they do not have a single physical substrate. They arise through declarations and through society's recognition of their functions. For Searle, a game is the paradigm of any social object. The rules of the game create a reality that shapes participants' behavior as powerfully as the laws of physics.
Hyperreality and Simulacra.
Jean Baudrillard, in his theory of simulacra, argues that in the modern world, representations of reality have replaced reality itself. We live in an era of hyperreality, where symbols and images, simulacra, no longer have an original in the physical world. Examples include virtual identities on social media, financial derivatives, and media events that happen only on screens, yet shape the lives of millions. In 2025, generative AI and deepfake technologies push this trend to the extreme, erasing the boundary between authentic and artificial. Politics in the age of hyperreality becomes the management of simulacra, a struggle of symbols and avatars rather than real programs. We've gradually reached our final part.
Metaphysics and quantum non-duality. New horizons.
One of the boldest hypotheses of 2025 is an attempt to give scientific grounding to non-dual Eastern teachings. Maria Strome, a physicist and professor of nanotechnology, in her work Universal Consciousness as a Fundamental Field, proposes a mathematical bridge between quantum field theory and metaphysics. The Strome model, consciousness as fundamental. Unlike the materialist approach, where consciousness is a byproduct of the brain, Strome argues that consciousness is a fundamental field of the universe, phi. In this model, mind, an impersonal source of all potential. Consciousness, a field of awareness that serves as the substrate for space, time, and matter. Thought, a creative mechanism that collapses the potential of the field into the specific experience of an individual.
Individual consciousness in this theory is only a localized excitation in the universal field. When the biological system breaks down, the wave quiets, but the field itself remains unchanged. This concept echoes the Indian philosophy of Vedanta, which compares consciousness to an ocean and individuals to waves on its surface.
Innovative research from Cornell University in 2025 reveals new dimensions of how biology shapes social reality through the olfactory system. It was shown that people can subconsciously evaluate potential friendship and social compatibility based on scent. Key findings about olfactory reality. Detection speed. The brain recognizes changes in smell in as little as 60 milliseconds, comparable to visual and auditory processing speed. Predictive nature. The olfactory system operates as a predictive model, combining memory, expectations, and current stimuli to interpret the environment. Climate factor. Rising temperature and humidity change the volatility of scent molecules, directly affecting how people perceive one another and their surroundings. This underscores that even subtle aspects of reality, like smell, play a fundamental role in assessing compatibility and safety at a pre-conscious level.
The religious view, from dogma to experience.
Traditional religions also offer their maps of reality. In Christianity and Islam, reality is centered on God as the first cause. In Christianity, the material world is acknowledged as real, but it is only part of a broader spiritual reality. Death is seen not as an end, but as a transition from one form of existence to another. In Islam, the concept of al-haq, the true reality, points to the idea that everything that exists is only a shadow of divine truth. Islamic philosophy emphasizes the distinction between the manifest world, zahir, and the hidden inner essence, batin. Across different schools of Christianity and Islam, the emphases vary, but the general direction is roughly this. However, among religions, Buddhism offers one of the most developed models of experience and causality and one of the most sophisticated analytic models of reality. Some of its positions also resonate in interesting ways with ideas in modern physics. The Madhyamaka school of Buddhism, founded by Nagarjuna, asserts that phenomena lack inherent existence, svabhava. Things are empty of independent existence because they arise in interdependence. Reality is not a collection of objects, but an endless network of relations. The doctrine of the two truths in Buddhism divides the world into conventional truth, samvriti satya, the world of familiar objects, words, and concepts. This is how reality appears in everyday life. And ultimate truth, paramartha satya, emptiness, shunyata, the true nature of all phenomena, beyond conceptual definitions. Emptiness is not nothingness, but a mode of existence, the absence of inherent self-being. This can be compared with quantum entanglement. A particle does not have definite properties until measurement and is inseparably linked with the rest of the universe. Modern science suggests that reality at the fundamental level is probabilistic and non-local, which may align with the Buddhist view of emptiness as the absence of self-being and as an open space of unlimited potential.
Dzogchen, direct recognition of reality.
If Buddhism offers a deep analysis of emptiness, the Dzogchen teaching, the Great Perfection, points to a direct experience of reality beyond all duality. Here, reality is understood as the ground, shi, which is neither existent nor non-existent. In Dzogchen, existence and non-existence are two sides of one coin that lose their meaning upon direct recognition. The manifest world, energy, forms, thoughts, and its empty essence are inseparable. This awareness is called rigpa, pure presence in which the subject-object duality dissolves. Core aspects of reality in Dzogchen. Kedag, primordial purity, the emptiness and openness of reality. This is not mere absence, but a ground that is itself clear, luminous, and aware. It is awareness-imbued emptiness, not nothing. Lundrub, spontaneous presence, the continuous unfolding of energy and forms. Unity, rigpa, the recognition in which Kedag and Lundrub are experienced as inseparable. Thoughts arise in the mind like reflections in a mirror. The mirror is not stained by reflections, and the reflections are not separate from the mirror. This view differs radically from materialism. Here, reality is not what is out there, but what is present right now in the field of awareness. Dzogchen, Teachings of the Great Perfection, offers concepts that can resonate with quantum physics. Kadag, Primordial Purity, emptiness is the basis of everything. This resembles the quantum vacuum with its infinite potential. Lundrub, Self-arising presence, the spontaneous manifestation of forms from emptiness. This resembles the emergence of particles from quantum fluctuations. Rigpa, non-dual awareness uniting emptiness in appearances. Scientific analysis of these states suggests that reality is not made of separate objects, but is an inseparable web of interdependence, pratitya samutpada. In quantum physics, this shows up as entanglement, where particles remain instantly correlated regardless of distance, what Einstein called spooky action at a distance.
Conclusion: an integral view of being.
Analyzing the nature of reality through multiple disciplines leads to the conclusion that the world is not what it seems at first glance. The apple on the table is simultaneously a dynamic state of quantum fields, almost entirely empty space, a biological icon in the human survival interface, a controlled hallucination predicted by the brain, an object in an informational network, possibly part of a global simulation, a manifestation of a single non-dual awareness, if we view reality through Eastern philosophy and new physical models of consciousness. Each of these approaches describes only one layer of a multidimensional architecture of being. Modern science in 2025 increasingly considers hypotheses in which information and consciousness are more fundamental categories than matter and energy. In this system, the human being is not a passive observer. Consciousness, biology, and social agreements actively construct the reality in which a person lives. True reality likely lies beyond any conceptual model, in the domain of direct experience that Eastern masters have spoken about for thousands of years, and that some directions in contemporary physics and philosophy of science have approached in a surprising way.